Somewhere on a factory floor, a designer is holding a finished chair. It looks exactly like a chair. But before it's approved for production, it has to pass a test that has nothing to do with comfort, and nothing to do with how it looks in a showroom. It has to fit, along with several identical chairs, inside a flat cardboard box small enough to stack efficiently on a truck. If it doesn't fit that box, the chair doesn't exist, no matter how good the design is otherwise. That single constraint, decided before a single leg or joint is ever drawn, quietly shapes almost everything else about the company selling that chair. The company is IKEA, and the story of how it built itself around that one constraint is bigger than any single product it sells. Most explanations of IKEA start in the wrong place. They start with the store, the maze-like layout, the arrows on the floor, the meatballs positioned right before checkout. That story isn't wrong, but it's incomplete, and it misses the actual foundation the whole company is built on. The real story doesn't start in the store. It starts in the box. IKEA isn't primarily a furniture company that happens to use flat packaging. It's a packaging and logistics system that happens to sell furniture. And once you see the company that way, almost every decision it makes starts to make a different kind of sense. To understand why the box matters this much, you have to understand what furniture actually costs to move before IKEA came along. A finished, fully assembled table is, from a shipping perspective, an extremely inefficient object. It's mostly empty space, four thin legs holding up a flat surface with a huge volume of air trapped in between. When a traditional furniture company ships a finished table, it's paying to transport that air over and over again, on every truck, on every container, across every border the product crosses. Multiply that inefficiency across an entire warehouse full of assembled sofas, bookshelves, and wardrobes. And you get an industry where a large share of the cost isn't the wood or the fabric, it's the empty space between the legs. IKEA's founding insight, developed gradually rather than arriving as a single flash of genius, was that if you remove the legs from the table before shipping it, that wasted space disappeared. A flat-packed table takes up a small fraction of the volume of the same table fully assembled. Suddenly, a single truck that could previously carry a few dozen assembled tables could carry several times that number in flat boxes. A shipping container that used to move a modest quantity of finished furniture could now move a warehouse's worth of it. This is the first and most important number in the entire story, even though it's rarely stated with precision. Flat packing doesn't just save some space, it can multiply the amount of product that fits into the same physical shipping capacity by several times over, depending on the item. That multiplication effect touches every single cost downstream of it. Fewer trucks needed per unit sold, fewer containers, less fuel per item shipped, less warehouse space required to store the same number of products. But here's where the story gets more interesting than a simple packing trick, because achieving that kind of space efficiency isn't something you can bolt onto furniture after it's already been designed. You can't take an existing fully formed chair, designed the traditional way, and simply disassemble it into a flat box after the fact and expect the same gains. The compression only works if the product is designed from its very first sketch around the shape and limits of the box it will eventually travel in. This is the actual core of IKEA's system, and it's the reason flat packing isn't a footnote to the company's story. It's closer to being the company's actual product. At IKEA, packaging isn't something that happens to a product once the design is finished. Packaging is a design input from the very beginning, on equal footing with appearance, function, and material cost. A designer working on a new shelf or table doesn't just ask what it should look like or how strong it needs to be. They ask how its individual components can be shaped to nest together as tightly as possible inside a flat, rectangular volume. A tabletop might be redesigned with a slightly different edge profile, specifically so that four of them can stack with almost no gap between them. Legs might be shaped as flat panels rather than round cylinders, not purely for aesthetic reasons, but because a flat panel packs against another flat panel far more efficiently than a cylinder packs against a cylinder, where curved surfaces leave wasted gaps no matter how you arrange them. This is why so much of IKEA's furniture shares a recognizable visual language. Clean edges, flat surfaces, minimal ornamentation, not purely because of a particular design taste, but because that visual language is what naturally emerges when a product has to satisfy the box before it satisfies the eye. The look people associate with IKEA is to a significant extent a side effect of a packing constraint dressed up as a design philosophy. This same logic extends to materials. Solid wood furniture is heavy, and weight is its own cost. Heavier shipments cost more to move regardless of their volume, and solid wood also tends to warp, crack, or split if it isn't handled and stored with care, which becomes a bigger problem the more times a piece of furniture changes hands between a factory and a customer's home. IKEA's widespread use of engineered materials, particle board and fiberboard cores, covered with a printed or laminated finish designed to resemble wood grain, isn't simply about finding the cheapest possible material to hit a low price point, though cost is certainly part of it. These engineered materials are also lighter than solid wood, more dimensionally stable in a flat packed state, more resistant to the kind of warping that solid lumber suffers when stacked flat under pressure for weeks in a warehouse or a shipping container, and easier to produce with total dimensional consistency at the massive volumes IKEA operates at. In other words, the material choice and the box constraint reinforce each other. A material chosen purely for its shipping-friendly properties then becomes the material that also happens to make the company's low price points achievable, which then becomes the material that also happens to define IKEA's visual identity to millions of shoppers who've never thought about any of these underlying reasons at all. Once you understand this, an entirely different picture emerges of what an IKEA store actually is. The bright, oversized showroom that customers walk through, filled with fully staged rooms, styled sofas, decorated shelves, looks like the heart of the business. It isn't. It's closer to being a very elaborate advertisement wrapped around the real engine of the store, which sits in a completely different part of the building. The warehouse. A traditional furniture retailer typically needs a large sales floor and a comparatively modest storage area, because it's storing bulky, pre-assembled items that take up enormous amounts of space per unit. IKEA inverts this relationship because its products live in the store as flat, stackable boxes rather than assembled furniture. An IKEA warehouse can hold an enormous volume of actual inventory in a relatively compact footprint, stacked floor to ceiling on industrial shelving, organized with the same density logic that governs the shipping containers that brought the products there in the first place. The showroom exists mainly to let customers see, touch, and fall in love with a fully assembled version of a product they will never actually carry out of the building in that form. What they carry out is the flat box sitting one floor below or one aisle over. In the warehouse section, most stores route customers through on their way to checkout. The store isn't primarily a place to shop. It's a physical interface between a showroom that sells the idea of a product and a warehouse that stores the shippable reality of it, and the entire building is architected around making that handoff from idea to box as frictionless as possible. This is also where the much-discussed store layout actually connects back to the packaging logic, rather than existing as some separate psychological trick bolted onto the business. Because the warehouse holds the real inventory in a dense, standardized format, and because a huge share of the company's cost advantage depends on customers reliably finding, purchasing, and successfully transporting their own flat-packed items, the physical journey through an IKEA store is engineered to reinforce the same standardization that governs the boxes themselves: consistent routes, consistent signage, consistent placement of the warehouse pickup area relative to checkout, repeated with only minor variation across stores on different continents. The layout isn't primarily about maximizing impulse purchases, even though that's a real side effect. It's about making an enormously complex, standardized global logistics system feel, to an ordinary shopper, like a simple, guided walk through a pleasant showroom. Now we arrive at the part of the system that's easiest to notice and hardest to think through clearly: the customer doing the final assembly themselves, at home, usually with nothing but a small hex key included in the box. It's tempting to frame this purely as a cost-cutting measure. IKEA doesn't pay workers to assemble the furniture, so the customer effectively works for free, and the company pockets the difference. That framing isn't wrong, but it undersells what's actually happening. because self-assembly isn't just a labor question. It's the final, necessary step in the exact same logic that governs everything upstream of it. A piece of furniture that ships flat, disassembled into individual panels and components, doesn't magically reassemble itself once it arrives at a customer's home. Someone has to do that assembly, somewhere in the chain, and the company has a choice about where in the chain that labor happens. It could happen at the factory, before shipping, but then the product would need to ship assembled, undoing all the space savings that made it affordable to move in the first place. It could happen at a local distribution center closer to the customer, but that would require an enormous, expensive network of local assembly facilities in every market IKEA operates in, adding cost and complexity back into the system in a different place. Or it can happen at the one point in the chain where labor is, from the company's perspective, essentially free, inside the customer's own home, using the customer's own time, energy, and mild frustration with a set of wordless picture instructions. Self-assembly, seen this way, isn't a separate feature of the business. It's the last mile of the same flat-pack logic that begins on the factory floor. The customer isn't just a buyer at the end of the chain. They're the final unpaid station on IKEA's own production line, completing a manufacturing step the company deliberately chose not to do itself, because doing it themselves would have broken the shipping economics that make the whole system affordable in the first place. This reframing also explains something that otherwise looks like a strange design compromise. The now famous wordless assembly instructions made of nothing but simple line drawings and numbered steps. These instructions aren't just a nice touch of universal design thinking, they're a necessity created directly by the scale of the system. A furniture company selling a handful of products in one country could afford to write detailed, language-specific instructions with actual sentences. A company selling thousands of products, assembled by customers speaking dozens of different languages across dozens of countries, cannot realistically produce and manage that many localized instruction booklets without enormous ongoing cost and a serious risk of translation errors, causing assembly mistakes. Wordless, illustration-only instructions solve a logistics and localization problem as much as a design problem. One single instruction sheet works unchanged whether the customer is in Stockholm, Tokyo, or Toronto. Put all of these pieces together and a very different shape of company emerges than the one most people picture when they think of IKEA. It isn't fundamentally a furniture retailer that happens to have a clever packaging gimmick. It's a company where a single physical constraint, the dimensions and stackability of a flat cardboard box, was allowed to work its way backward through every other part of the business, into the shape of individual components, into the choice of core materials, into the architecture of the store itself, into the design of the warehouse relative to the showroom, and finally into an unspoken redistribution of labor that turns every customer in every country into an unpaid final assembly worker. Almost nothing about the visible brand, the visual style, the low prices, the store experience, even the Scandinavian design reputation, exists independently of that original constraint. Each of those things is closer to being a downstream symptom of the box than a separate strategic decision made on its own terms. It would be inaccurate, though, to present this system as a flawless piece of engineering with no real costs of its own, and it's worth being honest about where the model creates friction rather than efficiency. The most obvious cost sits exactly where the savings are captured, with the customer. The hours spent assembling furniture, the frustration of a missing screw or a misread diagram, the physical strain of building a heavy wardrobe alone in a small apartment. These aren't imaginary costs just because they don't appear on an invoice. They're real labor, transferred from a paid employee to an unpaid customer, and not every customer values their own time and effort the same way. For someone with plenty of time, adequate space, and some tolerance for instructions, that transfer feels like a fair trade for a lower price. For someone with limited time, a difficult living situation, or a physical limitation that makes assembly genuinely hard, that same transfer can feel less like a bargain and more like an unpaid tax on convenience. The material compromises carry their own cost as well. Engineered wood products, chosen partly for their shipping and manufacturing efficiency, generally don't match solid wood furniture in long-term durability, repairability, or resale value. A solid wood table can be sanded down and refinished decades later. An engineered board equivalent generally can't be repaired the same way once its surface is damaged, and it's far less likely to be resold, passed down, or restored the way older, heavier furniture traditionally was. The flat pack system optimizes hard for affordability and shipping efficiency at a specific moment of purchase. It isn't optimized for how a piece of furniture ages over 10 or 20 years. And that trade-off is built into the model from the very first design sketch, not something IKEA stumbled into by accident. There's also a structural fragility built into standardization itself, because the entire system depends on components shaped for shipping efficiency at massive consistent scale. It's difficult for IKEA to offer the kind of deep customization, unusual sizes, unique material combinations, one-off requests that smaller, traditional furniture makers can provide relatively easily. The same standardization that makes the global system affordable also makes it comparatively rigid, and any attempt to introduce meaningful customization threatens to undo the packing efficiencies the entire cost structure depends on. And the model depends on a functioning, predictable, low-cost global shipping network to work at all. A system built around minimizing the cost of moving huge volumes of flat boxes across long distances is by definition exposed to anything that disrupts global shipping capacity or dramatically raises its cost. Port congestion, container shortages, sharp increases in fuel prices, or supply chain shocks that ripple through the shipping industry as a whole. A company whose core advantage is logistics efficiency is also necessarily a company whose core advantage is vulnerable to logistics disruption in a way that a smaller, regionally based furniture maker sourcing and selling within a single country simply isn't. Taken together, none of this means the flat pack system is a flaw disguised as a strength. It means the system is exactly what it looks like, once you trace it back to its origin. A single, unglamorous constraint about how efficiently you can pack a table into a box, followed all the way through to its logical conclusion, across materials, design, architecture, and even the division of labor between a company and its customers. IKEA didn't just find a clever way to sell furniture cheaply, it built an entire operating system out of one packing decision, and then organized nearly everything else the company does, visibly or invisibly, around protecting the efficiency of that one decision.